One farmer. No chemicals, no fertilizer, no tilling, no weeding. For 40 years, Japanese agricultural scientists called Masanobu Fukuoka a fool. His rice fields looked like a mess. His barley pushed up through tangled weeds and scattered straw. He hadn't touched his soil with a plow in decades, and he had no intention of starting. His neighbors shook their heads. The Ministry of Agriculture refused to fund him. University experts dismissed him at conferences. Then the yield data came in, season after season, and it didn't match what any of the models predicted. And the scientists went very, very quiet. The land that taught him everything. In 1937, a 25-year-old plant scientist named Masanobu Fukuoka had a breakdown. Not a slow decline. A sudden, total collapse. He was working as a customs inspector for the Yokohama city government, inspecting plants for disease, when he was hospitalized with acute pneumonia. He recovered physically. But something else didn't recover with him. Lying in that hospital in the small hours of the morning, watching the city lights blur through the window, he found himself unable to answer a question that wouldn't leave him alone. What is the point of any of this? He resigned his job. He went home. Home was a small farm on the island of Shikoku, in Ehime Prefecture, on the southwestern coast of Japan. His father grew citrus and rice. The land had been in the family for generations. Fukuoka told his father he wanted to farm it differently. His father looked at him the way fathers look at sons who have just quit a respectable government job to go play in the mud. He had that particular kind of silence that says everything, but he let him try. What happened next took years to crystallize into a method, but the seed of it came from a single moment Fukuoka described for the rest of his life. He was walking through an abandoned field, land that had been left alone, untended, unremarkable, and he noticed something that should have been obvious but somehow wasn't. The field was doing fine, better than fine. Grasses and weeds had reclaimed it. Insects had returned. The soil was soft and dark where it had been hard and pale. Nothing had done this. No one had done this. The field had simply been left alone long enough to remember what it was supposed to be. Fukuoka stood in that field and asked himself the question that would define the next 7 decades of his life. What if farming had it backwards? What if the best thing a farmer could do was less? He went back to his father's farm and started subtracting. First, he stopped tilling. Then he stopped applying fertilizer. Then he stopped using pesticides. Then he stopped flooding the rice paddies in the traditional Japanese method. One by one, he removed every intervention that conventional agriculture considered non-negotiable. And one by one, he watched to see what the land did without them. The land, it turned out, had opinions. Quick question before we go any further. Leave me a comment. Had you heard of Fukuoka before this video? And if you had, what did you think he was? Philosopher? Crank? Genius? I want to know. What do nothing actually means, and why that's the wrong translation. Here's the thing that trips everyone up when they first encounter Fukuoka's method. The phrase most people associate with him is do-nothing farming. He used it himself in a somewhat mischievous way because he knew it would provoke people. But it is genuinely the worst possible description of what he actually did. Natural farming, the term he preferred, was built on 4 principles. No tilling, no fertilizer, no pesticides, no weeding. That list sounds like a recipe for a catastrophic crop failure, and if you handed it to a conventional agronomist cold, they would tell you exactly that. But what Fukuoka was describing wasn't the absence of management. It was the replacement of management with observation. It was the discipline of watching what a piece of land actually needed, rather than imposing on it what a textbook said it should have. Take no-till. Conventional agriculture tills the soil to control weeds, aerate the ground, and prepare a seedbed. The logic seems sound. But tilling also destroys fungal networks that have taken decades or centuries to develop. It exposes soil carbon to the air, where it oxidizes and escapes. It kills the earthworms and microbes doing the slow, invisible work of building soil structure from the inside. Every time you till, you are borrowing against the future to pay for the present. Fukuoka stopped borrowing. Instead of tilling, he used straw. After each harvest, he scattered the straw from the previous crop across the field, uncut, covering the soil the way a forest floor covers itself with its own fallen debris. The straw suppressed weeds, held moisture, and slowly decomposed into the soil, feeding the organisms he was counting on to do his fertilizing for him. Instead of planting seeds directly, he developed what became one of the most copied innovations in small-scale agriculture: the clay seed ball. Seeds coated in clay and compost, rolled by hand, scattered across the field before the rains came. The clay protected the seed from birds and rodents. The rain dissolved it at exactly the right moment. No tractor, no seed drill, no fuel. Just a farmer walking through a field, scattering balls of clay the way a bird scatters berries. And instead of flooding his rice paddies, the foundational technique of Japanese rice cultivation going back thousands of years, he let the ground stay dry, trusting that the right varieties, planted at the right time, with the right straw covering, would manage their own moisture needs. His neighbors thought he had lost his mind. His father was not entirely sure they were wrong. And honestly, reading it back now, it does sound a bit like the agricultural equivalent of canceling your gym membership and expecting to get fitter. Except in this case, it worked, which is the part nobody saw coming. The part where scientists laughed. Let's be honest about the context Fukuoka was working in, because without it, the story doesn't make sense. The 1950s and 60s were the era of the Green Revolution. This was the moment when agricultural science genuinely saved hundreds of millions of lives. Norman Borlaug's high-yield wheat varieties, the explosion of synthetic nitrogen fertilizers, mechanized irrigation on a scale the world had never seen. In the span of 2 decades, countries that had been facing famine were producing surpluses. The science was real. The results were real. To be an agricultural scientist in Japan in 1960 was to be part of one of the most successful technological projects in human history. And here was Fukuoka, on his little farm in Eihime, telling everyone to use less, to add nothing, to trust the weeds. The Japanese Ministry of Agriculture was not interested. The agricultural universities were not interested. The extension officers who visited farms across Japan spreading the gospel of modernization were definitely not interested. Fukuoka applied for recognition and funding through official channels. He was rejected. He presented his findings at conferences. He was dismissed. One official, in a story Fukuoka told with obvious amusement in later life, visited his farm, looked at the tangle of straw and clover and weeds and rice growing through all of it, and told him flatly that his fields were an embarrassment to Japanese agriculture. Fukuoka wrote later that this was one of the most encouraging things anyone ever said to him. If the method had looked like what everyone else was doing, he reasoned, he was probably doing something wrong. There is something almost comedic about the situation when you step back far enough. A man whose fields were consistently producing competitive yields, whose soil was visibly improving decade by decade, being told by officials whose own extension recommendations were quietly degrading the land beneath them that he was the one doing it wrong. The audacity of the embarrassment runs in both directions. Fukuoka just happened to be the only one who could see it at the time. But 40 years is a long time to be told you are wrong. 40 years of rejection letters. 40 years of your neighbors shaking their heads. 40 years of watching the modernization juggernaut roll past your farm without stopping. There is a version of this story where Fukuoka gives up sometime around 1965 and the world never hears from him. He didn't give up. He just kept farming. And every year, quietly, the soil on his hillside got a little darker and a little deeper, and held water a little longer than it had the year before. The numbers that shouldn't have been possible. Here is where it gets interesting. And by interesting, I mean the kind of interesting that makes agricultural scientists put down their coffee and stare at a page for a long time. Fukuoka's rice yields, measured over decades, were comparable to those of his conventionally farmed neighbors. Not lower, comparable. In some years, higher. This should not have been possible. His fields received no synthetic nitrogen, no phosphorus supplements, no managed irrigation. By every model of agricultural productivity available in the 1960s, his fields should have been exhausted and underperforming within a handful of seasons. They weren't. But the yield numbers were almost the secondary story. The primary story was what was happening to his soil. Over 4 decades of no-till, the organic matter content of Fukuoka's soil increased steadily. Soil that had been shallow and compacted when he started farming it became deep and loose and dark. His fields, which sat on a hillside subject to the heavy rains of western Japan, retained water far better than the tilled fields below them. During dry spells, his crops held on longer. During heavy rains, his soil absorbed rather than shed the water, reducing runoff and erosion to almost nothing. Meanwhile, next door and across the valley, the conventional fields told a different story. Decades of tilling had steadily depleted soil organic matter. Fields that had once required modest inputs of fertilizer now required larger ones to produce the same yields. Irrigation demands crept upward as water retention dropped. The soil was getting thinner while Fukuoka's was getting thicker. 2 farms, same island, same rainfall, same crops. Diverging completely in opposite directions over 40 years because of what one farmer chose not to do. To be fair, and we will come back to fairness later, Fukuoka's farm was not a controlled experiment. There was no randomized trial. There was no comparison plot with rigorous controls. What he had was decades of careful observation on one piece of land, which is powerful and real, and also genuinely limited as scientific evidence. The researchers who eventually started paying attention to him knew this. But they also couldn't ignore what his soil looked like after 40 years of being treated the way he treated it. Some data points are hard to argue with, even when the methodology isn't perfect. One book changed everything. In 1975, Fukuoka published a book called The One Straw Revolution. It was, by the standards of Japanese agricultural publishing, a very strange book. It was part farming manual, part philosophy, part extended argument with the entire structure of modern civilization. It talked about soil and also about emptiness, about rice and also about the nature of knowledge. It was not written for agricultural scientists. It was written for anyone who had ever looked at the way the world was being managed and felt a quiet unease they couldn't quite name. It sold modestly in Japan. Then it was translated into English in 1978, and something unexpected happened. It found its way into the hands of people who were not farmers at all. Activists, philosophers. Back to the land communities in California and Vermont. The counterculture pipeline, which had spent the previous decade building a sprawling network of alternative agriculture experiments, seized on Fukuoka as a kind of prophet. He was embraced by people who had never grown rice and had no particular interest in starting. This could have been the end of it. Counterculture enthusiasm has a way of validating ideas without actually testing them. The history of alternative agriculture is littered with methods that were celebrated by enthusiasts and never examined by scientists, and quietly died when the harvest didn't come. But something else happened alongside the enthusiasm. A smaller, quieter group of people read the book and started checking his claims. soil scientists in the United States who had been independently noticing problems with tillage, agronomists in Australia who were watching their topsoil blow away, researchers in India who were working with farmers whose land was degrading faster than the models predicted. They weren't reading Fukuoka as philosophy. They were reading him as a hypothesis, and they were designing experiments to test it. The One Straw Revolution is now in print in more than 25 languages. It has sold millions of copies. It is assigned reading and agronomy departments at universities that would have laughed at Fukuoka in 1965. The book didn't change farming by itself, but it gave a name and a face and a story to something that the data was beginning to suggest was true. What the soil was doing the whole time. Underneath Fukuoka's fields, something extraordinary was happening. He didn't have the scientific vocabulary for it in 1947. Frankly, the scientific vocabulary for it barely existed in 1975. But the organisms responsible for his results were there the whole time, doing their work in the dark. Mycorrhizal fungi. The word sounds like something you'd find on a biology exam you didn't study for, but the concept is one of the most important in all of ecology. These are fungi that live in and around plant roots, forming networks, sometimes called the Wood Wide Web, which is a name I personally think scientists came up with specifically to get non-scientists to pay attention, and I respect that entirely. That connect individual plants to each other and to the wider nutrient system of the soil. In exchange for carbon from the plant, the fungi deliver phosphorus, nitrogen, water, and chemical signals that help the plant detect drought, disease, and competition. A single teaspoon of healthy forest soil can contain several kilometers of fungal threads. A single teaspoon. Think about that the next time you complain about your commute. Tilling destroys these networks. Not just the threads themselves, but the architecture they spent years or decades building. Every time a plow passes through the soil, it is shredding a communication and supply network that the plants above it depend on. The plants survive this because farmers then pour in synthetic nutrients to replace what the fungi would have provided. But the fungi don't come back between seasons the way annual crops do. They take years to rebuild, if they rebuild at all. Fukuoka never tilled. So his fungal networks, whatever they were in 1947 when he started, had 40+ years to develop, mature, and extend. By the time researchers started paying serious attention to his farm, they found soil biology of a complexity that typically takes decades of abandonment to develop. But his land was actively farmed. That combination, managed and biologically rich, was almost unknown in conventional agriculture. It shouldn't have existed. And yet there it was. The straw mulch he scattered after every harvest was feeding the system. Decomposing straw feeds the bacteria that feed the fungi that feed the plants. The clover he grew between his crops was fixing nitrogen from the air, the way legumes do, delivering it to the soil without a bag of ammonium nitrate anywhere in sight. The whole system was cycling nutrients on a closed loop. Energy in, energy out, nothing wasted. No input from outside, just the land feeding itself, the way it had done for millions of years before anyone showed up with a plow. What Fukuoka had done, without fully understanding the microbiology of it, was protect an ecosystem that agriculture had spent 10,000 years systematically destroying. He just hadn't tilled it. That was the whole secret. And it was, at the same time, the simplest thing in the world, and the hardest. The world starts copying it. In 2014, a cattle rancher from Bismarck, North Dakota named Gabe Brown stood up at an agricultural conference and told a room full of conventional farmers that he hadn't tilled his fields in over 2 decades, that he used no synthetic fertilizers, that his soil organic matter had gone from 1.7%, about average for a degraded North American prairie, to over 11%. that his farm was profitable without government subsidies in years when his neighbors were being kept alive by government payments. The room was skeptical. North Dakota farmers are not the most immediately receptive audience for revolutionary agricultural philosophy. This is not a criticism. These are people who have watched trends come and go for generations and have the bankruptcies of optimistic neighbors to remind them of what idealism costs. But the numbers were hard to dismiss. And Brown wasn't speaking from ideology. He had nearly gone bankrupt 4 consecutive years in the late 90s. Hail, drought, flood, ice storm, each one taking a crop, and had rebuilt his operation from desperation, not principle. He had stopped tilling because he couldn't afford fuel. He had stopped buying fertilizer because he couldn't afford inputs. And then his soil had started recovering, and he had kept going because the math worked. Brown's story spread. His farm became one of the most visited agricultural operations in North America. He wrote a book. He gave talks. His methods, which aligned almost precisely with principles Fukuoka had been practicing since 1947, became central to the regenerative agriculture movement. In India, a former agricultural scientist named Subhash Palekar developed what he called zero-budget natural farming, drawing explicitly on Fukuoka's principles and adapting them for Indian conditions. By 2020, an estimated 700,000 Indian farmers were practicing some form of his methods. The state government of Andhra Pradesh committed to transitioning its entire agricultural sector, 6 million farms, to zero-budget natural farming by 2027. 6 million farms. That is not a fringe movement. That is policy. In the United States, the USDA's Natural Resources Conservation Service began offering financial incentives to farmers who adopted no-till and cover cropping practices. Practices that Fukuoka had been arguing for since the Eisenhower administration. No-till farming now covers over 35% of American cropland. In Australia, no-till adoption rates have reached similar levels. In Brazil, more than 60% of the country's vast grain-growing area is now farmed without primary tillage. The man who was told his fields were an embarrassment to Japanese agriculture is now, in practice if not always in name, the intellectual ancestor of one of the fastest-growing agricultural movements on the planet. The part experts still argue about. This is the moment in the script where I could wrap everything up neatly and tell you that Fukuoka was right, the scientists were wrong, and the world has finally seen the light. That would be satisfying. It would also be a bit dishonest. The science on no-till and natural farming is real and growing, but it is not a closed case. There are genuine, legitimate debates happening among serious researchers that deserve more than a dismissive paragraph. And this channel doesn't do dismissive paragraphs on complicated questions. The transition yield dip is real. When a farm switches from conventional to no-till or natural methods, yields typically drop for the first 3 to 5 years while the soil biology rebuilds. For a small family farm operating on thin margins, 3 to 5 years of reduced income is not an abstract inconvenience. It is a threat to the farm's survival. Policy that encourages transition without supporting farmers through that gap is easy to recommend and hard to live with. Telling a farmer that the soil will improve in a decade is cold comfort when the loan payment is due next month. Weed pressure is also real. Fukuoka managed weeds with straw mulch and timing, planting crops so they emerged before weeds could establish. This works, but it requires deep knowledge of specific local conditions, specific weed species, specific crop varieties. What works in Ehime Prefecture doesn't automatically translate to Iowa or Kenya or the Punjab Plains without significant adaptation. The researchers trying to scale these methods across different climates and soil types are doing genuinely difficult work, and they deserve more credit than they usually get. And the yield question, at scale, on degraded land, in the short term, remains contested. Some studies show no-till yields matching conventional. Others show consistent gaps of 5 to 15%, particularly for certain crops in certain climates. The gap tends to narrow over time as soil biology recovers, which is consistent with everything Fukuoka argued. But over time is cold comfort to a farmer who needs to pay rent this harvest. The honest version of this story is that Fukuoka was right about the direction. Whether every farm on Earth can get there, on what timeline, with what support, and with what trade-offs, those are still open questions, and the people asking them are not enemies of the method. They are doing the hard work of making it real. What Fukuoka got right. That we're still learning. Masanobu Fukuoka died in 2008. He was 95 years old. He died on the same island he had been born on, not far from the same hillside he had started farming in 1947. He had spent the last years of his life traveling to Africa, to India, to the deserts of Ethiopia and Somalia, trying to demonstrate that his methods could work not just in the wet temperate climate of Western Japan, but in degraded land anywhere. He scattered clay seed balls in Ethiopian dust. He planted trees in Somali sand. He was in his 80s when he did this. He was not a modest man. He was brilliant and combative and occasionally infuriating. He wrote books that mixed agricultural science with Zen philosophy in proportions that not everyone found helpful. He dismissed most of modern civilization's relationship with nature in terms that were not designed to win friends in government ministries. He was, in short, exactly the kind of person that institutional science is structurally designed to ignore. But what he understood, and what the science has spent the last 3 decades slowly catching up to, is that soil is not a medium. It is an ecosystem. A farm field is not a factory floor where you pour in inputs and extract outputs. It is a community of organisms in a relationship that took thousands of years to develop and can be damaged in a single season. When you treat it as a factory floor, it works for a while. Then it starts costing more and producing less. Then it fails. What Fukuoka proposed, subtracting intervention rather than adding it, trusting complexity rather than controlling it, working with biological time rather than against it, was not anti-science. It was a different kind of science. One that started with observation rather than hypothesis. One that measured success in decades rather than seasons. One that asked not what we can make this land produce, but what this land can become if we mostly leave it alone. He called it natural farming. He might just as easily have called it remembering. His farm in Ehime Prefecture is still being farmed today by people who learned from him. The soil is still improving. Every year, a little darker, a little deeper, a little more alive. Here's the thing about being called foolish for 40 years. It either breaks you or it clarifies you. Fukuoka was not broken by it. He seemed, by all accounts, almost amused by it, because he could walk out to his fields every morning and read the answer in the soil. The yield numbers were there. The earthworms were there. The water retention was there. The fungi were there, doing their invisible work in the dark, not waiting for anyone's validation. The Japanese Ministry of Agriculture, which declined to fund his research in 1960, now operates programs that promote no-till practices. The agricultural universities that dismissed his conference presentations now teach soil biology courses that describe, in precise molecular terms, exactly what was happening underneath his straw mulch. The USDA, the institution of a country that didn't translate his book until 1978, lists mycorrhizal health as a core metric of soil quality in its National Soil Assessment Framework. The One Straw Revolution is still in print. It has been in print continuously for nearly 50 years. The man who wrote it is quoted in scientific papers. His methods are studied at Wageningen University in the Netherlands, which is arguably the most respected agricultural research institution in the world. His clay seed balls have been used in land restoration projects on 6 continents. 40 years of being laughed at. A single book. 7 decades on one hillside. And now the world is catching up. Not to what Fukuoka invented, but to what he remembered. Some things don't need to be controlled. They need to be trusted. And sometimes the most radical act in agriculture, in anything, is to stop. Put down the tools. Watch what the land already knows how to do, and have the patience to let it. Fukuoka had that patience. The soil rewarded him for it. It took the rest of the world a little longer to notice. But they noticed. If this story made you think about the ground under your feet differently, leave me a comment. I want to know which part landed hardest. The fungal networks? The 40 years of rejection? The 700,000 Indian farmers? Tell me below. And if you're not subscribed yet, this is the kind of story we tell here. Hit the button. We've got more.